Good evening, everyone. So my name is Jyoti Sharma, and can you please confirm whether I'm audible to you or not?
Yes, you are audible, madam.
Okay, thank you. Thank you so much for your response. Okay, so this is week 9, and this session will be from 7 to 9. And let me show you what we already have covered. So, one lecture was all about primary treatment. So, we covered different screen, commutators, clarifiers. We talked about this, right? Then we talked about secondary treatment at length. We talked about and we discussed about activated sludge process at different processes that we may have under secondary treatment, and we also talked about tertiary treatment or the advanced treatment. But you need to care that even after primary treatment, secondary treatment, or even after tertiary treatment, you will get some sludge. So here you can see you are getting some sludge. So sludge is the kind of waste part that you will have after each step. So this is the raw or primary sludge that you will get. Here you also have this sludge. That sludge can return to the secondary treatment plant, or you can reuse it, or you can recycle it, but along with that you will have some waste in the form of sludge. So even after secondary treatment you will get some sludge. And after tertiary treatment, let's say if you are using RO, or if you are using ultraviolet radiation, even then you will get some sludge. And so right now what we have today to discuss is about the sludge, how we can dispose that sludge, what do you mean by that sludge, what different characteristics we have of this sludge. So we will talk about the sludge only for this session from 7 to 9. So let me show you very quickly that in primary treatment, we talked about grit chamber, equalization tank, sedimentation tank. And after that sedimentation tank, your sediments will be settled down at the bottom, and that will create the sludge. Okay, so this is the primary treatment that we learned, right? Then in secondary treatment, we talked about legumes, aerobic digestion, activated sludge process, anaerobic, UASB, biofilters, and even we talked about some advanced treatment options, and that would also give you some sludge, or you can say some waste part that we do not want in the water. Okay, so this is what we learned in one session about this secondary treatment. And we also learned in tertiary treatment how we can have different filters, and even after filtering your water will be clean, right? But in the filter you will have some sludge that you also need to dispose, you need to manage. So this is what we have learned. But today we will learn about the sludge and its generation, the type of sludge that we have. I already have talked about this, that you have primary sludge, secondary sludge, and tertiary, based on from which process you will get that sludge. Then property of sludge, we do have specific gravity of the sludge, even volume of sludge. So we will talk about some properties. Then why there is a need for the sludge management, and what different direction we may have. And we have different processes to treat the sludge. For example, it is a thickening, digestion, conditioning, dewatering, and drying, disposal. So we will learn about these treatment technique one by one. We will try to cover this one, and if we will not get enough time, then we will try to cover this industrial pollution control measure in the next week, right? So now I have MCQ questions. Once again, a lot of MCQs question, and I will encourage you to speak, to communicate, to participate in the discussion, because this is learning from both sides. Like, I will also learn from you, you will also learn from me. So this is kind of win-win situation that we will have. Don't worry about the wrong answers. You are encouraged. Whatever answer you are thinking that that option would be right, you just need to give that to me, and I will try to correct it, right? If it is wrong, and if it is not wrong, then this is great. Okay, so let me start with my questions. Okay, very basic question. how you can define the sludge? So we have four options here: a dry residue from combustion, a semi solid slurry after treatment processes, only wastewater solid, a dissolved substance in water. So what do you think? What
Op-
do you mean by sludge? Yes.
Option B, a
Option.
semi-solid, sir.
Okay. uh, Let me wait for Dia. Priscilla also joined me. So Dia also gave me a B option. So yes, so right answer is yes, a semi-solid slurry from treatment processes. As we talked, we had primary treatment, we had secondary treatment, we had tertiary treatment, and in each of these, at each of these processes, we had some sludge, right? And this sludge, because we were treating the wastewater, right? So we had wastewater, and wastewater had some solid. So the waste thing that we will get, let's say after filtering, after activated sludge, or after some screening, what we will get is some liquid and some solid into that. So this will create a semi-solid slurry that we will get from the treatment process. That's why B is the right answer. Uh, Good evening, Priscilla. So, okay. um, I also have some explanation, and from this figure also you can see, or you can visualize what do you mean by this semi-solid slurry. So it is not the solid, and it is not completely the liquid. So this is semi-solid slurry that we will get after water treatment processes, right? Okay. The next question is, sludge solids are mainly, and you have four options here: dissolve only, suspended plus dissolve, and only organic matter.
Option C, slow solids
Uh,
are
Dia
mainly.
gave me B, and okay, let me see. Okay, Sagar gave me answer C, and Dia B, but yes, I agree with C, because it also have dissolved and suspended solid, and that's how it will create the sludge solid. Let me show you. Okay, I don't have this one, but just keep in mind that if we are talking about the sludge solid, then we have Fs and Vs, both. So Fs is fixed solid, so this is fixed solid, and this is volatile. So we have both type of solid in the sludge solids. So that's how C answer is the right one. Okay, so the next question is, which of the following is not a common source of sludge? Pit latrines and septic tanks, industrial effluent treatment, settled suspension from drinking water treatment, and groundwater recharge valves. Dia gave me a D
Option D.
answer.
Option D. Groundwater
Okay.
recharges.
Yes, Priscilla and Sagar also gave me D. So yes, this is odd one out, right? As I told you, if we are talking about the sludge, so sludge is what we will get after some treatment processes, right? After some treatment processes. So for example, if you have groundwater and if you are using ROs, right? So in that RO pipe also you will have some sludge that you have to, either you have to replace that filter that you are using in your ROs, or otherwise you have to clean that. So this is also the sludge that you are getting while treating your water that you will drink, right? So sludge you will get only after the treatment processes. So that's how this one, D is the odd one out answer, right? And that's how this will be, this is not a common source of sludge. Okay, so this is figure, again I'm showing you that we do have treatments, primary, secondary, and tertiary, and we will get sludge in each of these processes, right? activated sludge we will have. So in primary treatment we will mostly have dust or particles. In secondary treatment we will have some microbes and even some organic matter that we may have in the sludge, and in tertiary we may have some uh, inorganic contaminants that we may get in the sludge. Okay, so coming to the next question. uh, this is, I already have uh, told you that if we do have primary sludge, then this will be generated from, okay, so as I told you, primary sludge will come from primary treatment, secondary sludge will come from secondary treatment, but in that particular process we have different techniques. So for example, if it is a chemical precipitation, sedimentation, that will come under primary treatment, and whatever sludge we will get from that processes, that will come under primary sludge. In the secondary, after biological treatment, whatever we will get, this will come under the secondary. And we also have mixed sludge, so that is the primary and secondary sludge mixture. And we also have tertiary, that we will get after tertiary or advanced wastewater treatment. Okay, as we talked about that, right, that we have solid in the sludge, and that solid have fixed solid as well as the volatile solid. Which sludge type typically has higher total solid? Primary, secondary, both equal, depend on alkalinity. Which type of sludge should have highest amount of total solid in percentage? It is primary, secondary, both equal, or depends on alkalinity. Okay, so Priscilla gave me answer A. Pia also gave me A answer. Then yes, I also agree with A. And why this is the case? Why we are getting more total solid from primary as comparison to secondary? Because primary is the primary treatment, right? Initially whatever wastewater we will have, that will have the higher amount of solid, and after first treatment we will have less solid, and that less, the water with the less solid will give will go on to the secondary treatment, right? So that's how a higher total solid we will get in primary treatment or in the primary sludge. So here we have the numbers. So if we are talking about total solid, then primary is giving you 2 to 7%. In the secondary, you have 5 to 2%. If we are talking about the volatile solid, we will talk about this. What do you mean by this volatile solid as well? So if we are talking about volatile solid, in the primary, this is 60 to 80, but in secondary, it is 50 to 60. Nitrogen, it is 1.5 to 4. Most of the time, if it is total solid, nitrogen, phosphorus, potassium oxide, even thermal content, alkalinity, these will be higher in primary treatment. The sludge that we will get after primary treatment as comparison to secondary, except this one. And I will tell you why in the next question only. And so these are the numbers that uh, you may have in your mind whenever we are talking about the things that we will have in the sludge after primary treatment or after secondary treatment. Okay. Secondary treatment tend to have more nitrogen, as I showed you in that figure only, than primary sludge. What is the typical range? As I told you, like most of the sludge solid that we have is higher in primary sludge as comparison to secondary, but it is the nitrogen that is more in the secondary sludge as comparison to the primary sludge. And what is that typical range? Okay, let me see. So everyone gave me answer C only. So Yes, this is C, but my question is why? Why there is a more nitrogen? As I told you, right, in that figure, most of your solid or even inorganic or organic material, it was more in primary sludge as comparison to secondary. But why the nitrogen is more in secondary as comparison to primary? Can anybody give me answer or some guess about this? Why more nitrogen in secondary sludge as comparison to primary sludge, when most of the things are more in primary sludge as comparison to secondary? Okay, so the answer lies in the process itself. It is a, if it is a secondary process, right, if it is a secondary treatment, then we have the microbes, right? And whenever there is the microbes, then microbe needs nitrogen for protein synthesis. Okay, and some of the microbe will be the part of sludge as well, right? Some of them will be recycled, but some of them will be the part of sludge. So that will give you more nitrogen uh, in the secondary sludge as comparison to primary, just because of the presence of microbes. And even after the degradation or decomposition of that microbes in the sludge, you will get more nitrogen just because of the microbes. So that's how C is the right answer. I also have explanation for this. So primary sludge, that will mainly comes from sedimentation or settling. So mostly in the primary sludge, we will have grit, sand, or heavy organic matter, and it will have lower proportion of living cells, hence a lower nitrogen. But if we are talking about secondary sludge, then we have microbial biomass that will be the part of sludge, right? And that microbial cells are rich in protein and nucleic acid, and these protein and nucleic acid have nitrogen compounds in it, and that's how these biomass will contribute increment in the nitrogen content, that will be 2 to 5 of the total solid, right? So this is the right explanation why we do have more nitrogen in the secondary sludge as comparison to the primary sludge. Okay, in that table only, we also had the thermal content, because we will use that sludge to generate the electricity as well, to generate the heat. So we also need to know the thermal content of your sludge. So you have to tell me which pair is giving you the correct information. Primary 18,500 to 23,000, secondary 23,000 to 30,000, primary 23,000 to 30,000, secondary 500 to 1,500. Okay, so let me see the answer that you have given me. Okay, so I got A answer, I got C answer, so there is some kind of disparity. So the answer is A, that is primary sludge will give you the thermal content of 18,500 to 23,000. Let me show you once again the table. Tile permits. Okay, this is what we were talking about here. So if it is a thermal content, then this will be 23,000 to 30,000 in primary, and in secondary it would be the lesser one. Okay. Because we had the solids, right, total solid, and as I told you that total solid is made up of fixed solid and volatile solid in the sludge. And there is the question that will make you clear what is fixed solid and what do you mean by volatile solid, right? So this question is, which statement correctly distinguishes fixed solid from volatile solids in sludge? And we have four options here. Fs are mainly organic while Vs are inorganic. Fs burn off at 550 degrees Celsius. Vs remain as ash. Fs are inorganic residue. Vs are biodegradable organics. Both Vs and Fs are purely mineral matter. Let me see the answers. Priscilla gave me answer C. Okay, so Venkateshwar also gave me C answer. So yes, I also agree with this. If you are talking about fixed solid, so these are inorganic residue. It means that can't be burned out, right? That can be burned out. These solid, it means they are biodegradable under combustions. We can burn it out and we can make it volatile in nature. So these are biodegradable organics. So that's how C answer is the right one. And let me show you more explanation for this. So we have total solid, right? In that total solid, we have suspended solid and we have volatile, suspended and dissolved solid. And within this both, either we have suspended, so suspended are uh, that are uh, that are not dissolved, right? That are suspended on the surface of your, let's say, wastewater. So that's are the suspended. So we have fixed solid and volatile suspended solid. Under suspended solid and under dissolved solid, we also have that fixed and the volatile solid. And these are the fixed solid, means these are made up of inorganic compound, right? And that's how they can't be burned out. They can't be burned out. And these volatiles are made up of organic compound. These are biodegradable and under combustion we can burn it out, right? So these are the, and whenever we want to reduce the sludge, so the one process will be the combustion, because using that combustion, or you can say, right, one more term is incineration. Under this incineration we can burn out the volatile suspended solid, and this is how we can reduce the volume of the sludge. So based on what we have in that sludge, we will have different technique to manage that sludge, right? Okay. And because we were talking about that fixed solid, so this is the portion of sludge solid that does not burn off when heated to near to 550 degrees Celsius. And these are inorganic or mineral matter. Uh, for example, sand, silt, clay, salt, metal oxide, and grit. And their specific gravity is higher, and the significance is it can contribute to sludge weight and volume, because these are fixed in nature. They will be these will not be removed by combustion, right? And this reduce energy recovery potential because these are not biodegradable, and this will indicate your ash content after combustion. If we are talking about volatile solid, so the portion of sludge solid that burn off or volatiles when heated to near to 550 degrees Celsius, these are organic or biodegradable matter. These are mostly protein, fat, carbohydrate, microbial biomass. So for example, if you are having the wastewater from sugarcane distilleries, so sugarcane distilleries may give you, let's say, glucose in your wastewater. So that can give you more energy recovery, because we can do the combustion, we can burn these compound, and we can have more energy or more electricity generation from such kind of sludge. And it has specific gravity is lower as comparison to the fixed solid. So these are the difference between fixed solid and volatile solid. Okay, if sludge remain more volatile solid relative to fixed solid, its specific gravity will be closer to 2.5, 1, between 1.5 to 2, cannot be determined. What do you think? If you have more volatile solid, so we have more volatile solid as comparison to fixed solid, then specific gravity of your sludge will be closer to what? This is just based on one formula of the specific gravity of the sludge, and based on that formula you can easily tell me the right answer. Okay, Priscilla have C with the question mark. Okay, Venkateshra also gave me C answer. Sagar also gave me C. Okay, so it is 1, and let me show you how. Don't worry about this. Let me explain you. So first, just understand that what do you mean by specific gravity. So specific gravity is the density of substance to the density of water. Okay, and in the sludge it represents how heavy the sludge solid are compared to water. Okay, if we have a fixed solid, then if we do have more fixed solid, then solid sludge, or the sludge will have specific gravity near to 2.5. Okay, but if we have volatile solid, more volatile solid in the sludge, then your specific gravity would be similar to water, or you can say 1. So let me go back to the question again. So we have more volatile solid, right, as comparison to the fixed. So fixed may increase your specific gravity, but if you have more volatile, then this will be near to 1. Okay, because more volatile means more diluted solid that you have, and the gravity will be compared to the water, and whatever density we have of that volatile solid upon whatever density we have the water, that would be nearly similar, and that's how it will give you the 1 answer. But if you have more fixed solid, that can give you more specific density, that is near to 2.5. So that's how B answer is the right one. I think this is clear why I gave you the answer 1, but not 1.5 to 2.5. Is it clear? Anyway, so but why we are talking about this specific gravity, right? So we must have to understand what we will do with this specific gravity. So the simple thing is, if we do have higher specific gravity, that means solid will settle faster. It would be easier to remove in the clarifier if we do have. So it means it is more dense than the water, right? And that's how it will settle faster. If we do have a lower specific gravity, then this means slower settling, and we may need some different processes to make it manage, right? So specific gravity will tell you about the settling behavior of the sludge. Along with that, it will also have some influence on sludge thickening and dewatering. We will talk about this. What do you mean by thickening and what do you mean by dewatering? So it will also give some impact on thickening and dewatering. Then design of the treatment unit. So based on the density, we have to see what different size we need, if we need the digester or not. For example, if we do have more volatile solid, so what we can do is we can do the combustion, right? As I told you, we can use some digester as well. So based on that, we can see what kind of instruments or what kind of techniques we need further to dispose the sludge, how to manage the sludge, or even energy content estimation if we do have more organic rich sludge. So if we have more volatile solid, then this means we may get higher energy recovery potential. And if we do have mineral rich, so then we will get low energy recovery. So it means that one specific character or one characteristic of the sludge is the specific gravity, and specific gravity can define a lot of things about the sludge. Okay, so this is the one formula. If you want to calculate the specific gravity of sludge solid, this is sludge solid, right? Then this will be 1 upon Fs, Fs by Ts. So Fs is fixed, Ts is total solid, upon 2.5. As we know that for the fixed solid, we have specific gravity 2.5, and volatile solid divided by total solid upon 1. So this will be your calculation for specific gravity of sludge solid. But if you want to calculate the specific gravity of sludge, it also have water along with the solid, then this will be 1 divided by total solid fraction in sludge by sludge density plus water fraction in sludge by 1. I have one numerical question at the end on this specific gravity of sludge solid and total sludge. I think based on this based on this equation, I think you can solve that, but that is at the end, so don't worry right now. Typical volatile solid removal efficiency during sludge digestion is this is 10 to 20%, 25 to 35%, 40 to 50%, 60 to 70%. Let me see. Dia gave me C, Venkateshwara gave me D, Priscilla gave me C. Okay, so yes, this is C. So the first thing is you have to understand what is this sludge digestion. Sludge digestion may be aerobic and may be anaerobic. So this is, we are digesting the sludge in the presence of some microbes, right? And in the either in the presence of oxygen or in the absence of oxygen, that will reduce the volume of your sludge. And because we are using microbes, and microbes will mostly use your organic part of the sludge, and that's how it can remove the volatile solid. Okay, so what I'm saying is, to manage the sludge, one process is sludge digestion, in which we will use some microbes either in the presence or in the absence of oxygen. That's how we can remove volatile solid from the sludge in the form of, let's say, carbon dioxide or in water, right? But the typical efficiency to remove this volatile solid using sludge digestion is only 40 to 50. It means the sludge digestion is not complete solution for the sludge management, because first thing, it is just removing the volatile solid, and second thing is, under this volatile solid also, it is its removal efficiency is just 40 to 50%. It means we need more processes, more technique to manage the sludge. Okay, uh, a solid load before digestion computed as Ts influent is equal to Vs influent plus Fs influent is expressed in. So you need to tell me the unit uh, of your solid load before digestion. Under this digestion process, it is a volatile solid plus fixed solid. And you need to tell me the unit of this solid load that you will have before digestion. Let me see the answers. So I got B from Venkateshwara, and they also gave me B answer. So yes, this is kg per day. So because this is solid, so solid means we are having the weight, and every day we are giving it, right? So this is kg per day. Next question is, which of the following is considered an undesirable constituent in sludge? Nitrogen and phosphorus, pathogenic organisms, organic matter for fertilization, and water. I think odd one out you can easily tell me about this. Okay, so Venkateshwara gave me a B answer. Okay, they also gave me B. Uh, yes, I agree with your B, and why it is undesirable. So just think about that. Sludge is your whatever you are getting after the wastewater treatment. You will get the pure water, and whatever will be remaining will be your sludge. Okay, and this sludge may have a lot of things. If it's for example, I gave you example, right? If it is from sugar cannery or distillation, then you can get glucose into that, right? But if you are having some industries, that industries can give you, or for example, if it is a fertilizer industry that is giving you the wastewater, so in that wastewater you may get nitrogen or phosphorus. If you are getting wastewater from pharmaceutical, uh, then you can get some organic compound into that. um, for example, if you are getting this wastewater, let's say from some poultry, where we can have some eggs, so that water may also have some pathogenic organisms, right, into your sludge, because water will be purified, but what will be the remaining? Your pathogenic organisms. So sludge, so you have to see how you will dispose that sludge. If it has more nitrogen or phosphorus, if it has more pathogenic organism, then you can't dispose it directly, right? You have to do some treatment. So that's how it is very important also to see the content of the sludge that you have, right? So if we do have more pathogen undesirable constituent in sludge, and you have to treat it before throwing it away, right? So this is just little explanation that several organics and mineral component in the sludge may have fertilizing characteristics that we can use for as a manure. Some constituents are undesirable because of health and environmental risk, and undesirable constituents may be some metals. For example, if it is the arsenic, if it is mercury, let's say. So these are the metals. These are very toxic for human beings. So we should not have such metal in the sludge, and if this is the condition, we have to remove it. If we have trace organic contaminants into that, that is also undesirable. And if we do have the pathogenic organisms, and from so metals are even eventually poisonous to plant and animals, even for human being, even in the low concentration. And industrial wastewater have mostly these hazardous metals. Okay, as I told you, sludge may contain wide variety of pathogenic organism. That may be bacteria, virus, protozoa, helminthes, or fungi. And that's how we need some advanced technique to remove these pathogens. And we are doing is, we do have a lot of different uh, uh, different product that we are building in our industries, and that may also give you different kind of pathogen. And even if you are talking about biotechnology lab, that biotechnology lab is also giving you different type of pathogen in the, let's say, in the wastewater, in the sludge. So and some of the pathogen that we have, we haven't identified it yet, right? So this is very important for us, that if we do have sludge and in that sludge we have pathogen, we should not throw it away directly. Okay, so most chemical contaminants in sludge are mainly from domestic wastewater, industrial effluent, rainwater infiltration, natural microbial growth. Chemical contaminants, I think that is again a very easy question. Okay, let me see the answer that you people have given me. This is B. Okay, so everyone gave me B answer only. So yes, so we do have a lot of industries, chemical industries, fertilizer industries, that can give you chemical contaminants. So just see that domestic wastewater sludge have very low heavy metal content, but your chemical contaminant in the sludge is mainly coming from the industrial effluent. Okay, which of the following is least likely a major contributor to metal contamination in sludge? I think this is again a little easier question. Tanning and dye industries, coal power plants, nuclear power station, pharmaceutical. Nuclear power plant is giving you, let's say, cesium or thorium. So these are chemical metals. So it and even some cadmium rod are also used in nuclear power plant. So C is not the right answer. Okay, now Venkatesha gave me a D. Yes, pharmaceutical. Okay, so thing is that tanning and dyeing, dye industry, coal and nuclear, these are majorly giving you the metal contamination. Pharmaceutical may also give you metal contamination, but most of the time it is giving you the organic things, right? So this is, metal is somewhat inorganic in nature, but pharmaceutical mostly give you organic waste, right? So that's how D is the right answer. So here also have some explanation. If you are talking about the chemical industries, uh, so organic compound, tanning, pharmaceutical, laundries, oil, dyes, pigment. So these are that we are getting from the chemical industry. We can also get some. Okay, so because we are talking about the metal contamination, so we can get it from chemical industries. We can get from metal processing industries, from coal power plant, from nuclear power plant. No doubt we have pharmaceutical here, but if we are talking about major contributor, then these are more, right? So this is kind of relative. That's how a pharmaceutical is not exactly the right answer, but relative to other, we have to give pharmaceutical the right answer. Okay, I think you can give the answer to it. Which industry source contribute most to the organic compound in sludge? Pesticide and plastic industries, coal power plant, metal processing industries only, nuclear power station. So let me see the answers. Venkateshwara gave me A. Sagar also gave me A. Okay. So, yes, A is the right answer, because if we are talking about the pesticide or plastic are made up of polymers, and these polymers are mainly made up of CH, or sometime it is as sulfur also. So these are giving you the organic compound in the sludge. Can you tell me, okay, so if we are talking about pesticide, so can you tell me the name of one or two pesticide that we use that are very important for us? Any pesticide name that you know? Chlorine based or phosphorus based? Okay. So mostly we have chlorine based pesticide and phosphorus pesticide. Trichloro, you have to tell me more. Trichloro is not the proper word. MAP, cypermethrin, yes. So so this is if in phosphorus you have heard about malathion and parathion. Then in the chlorine based, uh, methyl chlor, something like that, we do have a lot of we do have a lot of pesticide. And if you know about that Bhopal gas tragedy, so can you tell me the name of that chemical? So this was kind of pesticide that
Methyl
uh,
isocyanide.
yeah, yes. So this is MIC. This is MIC, right? And this MIC is the part of, we do have carbonyl based pesticide, right? So I just want to tell you that we have pesticide that is made up of um organic compound, isocyanate, yes. And plastic, so can you tell me one polymer of plastic? One polymer anyway. Polyethyl, okay. PVC, polyethylene, yes. So I think everyone, you people know about this. So the answer is very clear that pesticide and plastic industry will give you the more organic compound in the sludge. So this is a little explanation. Anyway, so as I told you that sludge uh, disposal and management is one of the challenge for us. And if we do have more organic matter in the sludge, then we can generate some energy from sludge only. And if we do have more inorganic or fixed solid into the sludge, then the recovering the energy is little less. So you have to tell me the method primarily focusing on recovering energy and minerals. So organic recycle, thermal method, deposition, environmental utilization. So Venkateshwara gave me a B answer for this. So you need to tell me the method by which we can produce energy uh, after using that sludge? So yes, uh, yes, Priscilla. So the answer is B. That is thermal method only. So I have this one slide that I have taken from search slide. So this is, we do have a lot of methods by which we can recycle the energy and material from the sludge. And the one process is, and this is after thermal transformation. So we will use the thermal method. We will give some temperature to the sludge so that it can give us the energy and the material recycle. So, for example, the one is incineration. Then other thermal methods we have. This is pyrolysis, quasi-pyrolysis, gasification. And I already have explain the difference between this four terminology: incineration, pyrolysis, and gasification. I think you people are clear about these terminologies. Incineration is, uh, we are, can you remind me what do you mean by incineration, pyrolysis, and gasification? So pyrolysis is, in the absence of oxygen, we are doing the combustion, let's say, or we are degrading the sludge, or we are decomposing the sludge. Gasification is in the uh, partially we are giving the oxygen, like we are not giving oxygen 100%, but we are giving oxygen partially, and we are giving the temperature so that it can transform into some, it can give us some energy and some gases. And we also have incineration, where we are giving the oxygen with high temperature. So this is kind of combustion at high temperature, right? So it means if we are burning either in the presence or in the absence of oxygen, the sludge, we may get some energy, and we can also recycle some material, and that material will mostly be inorganic. So this is incineration. We are giving air, and this is your municipal solid waste. We are giving it, and this is how it will burn it out. Then after that, it will also filter this, so we will we will have some ash, and we will also have some air, and then it can also give you the energy. So this is incinerator. If we are talking about this pyrolysis, then here we are not giving oxygen. Then that means, if we are not giving the oxygen, then most of the time it will give you the hydrogen related compound. So for example, it will give you the hydrogen, it will give you the biomass, it will give you the biofuel. Ma'am, incineration is done in glass industries. Yes, we do. And in bio, and so after pyrolysis, what we will get 50% energy and 50% biochar. So this will be under pyrolysis. And we have pyrolysis, gasification, and here, and we have the waste in the form of sludge. And we have different temperature that we have to maintain, and different product that we will get. Either it is hydrogen, or it is carbon dioxide, it is carbon monoxide, it is methane, and we will also get some energy. So this is how we can burn the sludge to get some energy. Okay, I think this I already have given you the explanation. Rank these processes by oxygen availability from lowest to highest. Incineration, gasification, pyrolysis, gasification, incineration, pyrolysis, and pyrolysis, incineration, gasification. What do you think? Okay, so let me see. Priscilla gave me B, then I also get D answer. Okay, so there is a disparity in your options. Okay, so this is, as I told you, yes, okay, B is the right answer. So here we are giving full oxygen. In gasification, we are giving the partial oxygen. But in pyrolysis, we are either giving no oxygen or very limited oxygen. So that's how this will be from lowest to highest oxygen availability to burn the sludge, okay, and to generate the electricity. So we have more oxygen we are giving to the incineration process, limited or partial to the gasification, and no or very limited or very low to the pyrolysis process. So that's how B answer is the right one. Okay, so here again we do have difference between this pyrolysis, gasification, and incineration. This one is very clear. Then we also have some difference in the temperature range as well. Whenever we will have more oxygen, then more temperature range that we can provide. So this is 500 to 1200 degrees Celsius. Then what product we will get? So if it is the pyrolysis, then we can get biochar, bio-oil, and syngas. In gasification, we can have syngas and some char, but in incineration, we will have just heat, CO2, H2, and ash, because we are giving full oxygen. Okay, and here we will have the hydrogen based compound that we will have. If we are talking about the energy recovery, then pyrolysis will give you moderate, gasification will give you higher, and incineration will give you the maximum heat energy. This solid residue that we will get after burning off, in pyrolysis we will get biochar. In gasification we will have small amount of char, and in incineration we will have mostly ash. And purpose is mostly the energy recovery, and oxygen requirement is based on the oxygen availability. So this is the difference between these three techniques. Okay, using sewage sludge directly as fertilizer fall under industrial method, environmental utilization, thermal method, reclamation. So what they are saying is, sewage sludge that we are getting, we can directly use it as a fertilizer, and that will come under which category? So okay, everyone gave me B answer. So how can I deny with this answer? So yes, environmental utilization is a right answer. So just see here, uh, we have organic in the sludge, and what we can do is that organic we can use for as a fertilizer or for the soil formation, and we can use it, direct use of the treated sewage sludge as a soil fertilization will come under the environmental utilization. Under reclamation we can use that sludge to restore the degraded land. And another is mechanical, biological, and composting. So we can also use uh, sludge as the compost or as the manure. We will talk about this, right? Okay, what is the primary focus of sewage sludge treatment? Why we need to care much about sewage sludge treatment? We have four options: increasing sludge volume for easier handling, reduce weight, volume, and health risk, convert all sludge to energy only, avoid any disposal costs. Okay, so Diya and Venkateshwara. both gave me B. Yes. So, why we are doing this sludge treatment? The main purpose is just to reduce the weight, because reduce the weight, volume, and health risk. So, just think that if we are getting ton of wastewater and we are treating it, so tons of sewage sludge we will get along with that, and we can't throw it, right? We can't throw it directly somewhere, because that will again give you the wastewater. And that is, as I told you, and you also gave me the response, that sludge is the semi solid slurry. So this is neither the liquid, this is nor the solid. So this means it is giving you very bulky, it has a high volume, and it can give you even health risk, because it may also have pathogens. So the main focus of sewage sludge treatment is to reduce its weight and its volume and its health risk, right? So B is the right answer. Okay. So up to now, what we have learned, we talked about the type of sludge. It is primary, secondary, and tertiary sludge. We talked about the property of sludge, for example, specific gravity of the sludge. We talked about the need of sludge management. So, why sludge management is important for us, and some direction. Now, so this part has been completed. Now we will go on with the sludge treatment. So we do have different methods by which we can treat the sludge, and one you already have learned, that is the digestion. You also have learned about oxidation, a little bit oxidation, by which so oxidation, incineration, by which you can recover some energy. So you have learned a little about the sludge treatment and the technique, the digestion technique, and the incineration that will come under the oxidation. But we also have more technique or processes by which we need to treat the sludge. The one process is thickening. We will talk about this. Digestion, conditioning, dewatering, and drying, disposal. And for each of these processes, we need some proper technique, proper instrument, proper method. For example, if we want to dewater the sludge, then we do have different type of filter that we will use to dewater, right? If we want to do the conditioning, we need addition of some chemical in the sludge. So likewise, we do have different methods among these processes or among these methods. So we will talk about this at length from this slide, right? So this part is done, and now we will move on to this part. So up, I think up to sludge management direction, I think everything is clear, and now we will talk about this sludge treatment. Okay, as I told you, within these processes, we do have different methods, right? So, if we are talking about like this is our sludge, and let's say the first process is concentration. For concentration, we have different method, and most popular method are gravity thickening and flotation. We will talk about this. We have MCQs on gravity thickening and flotation. After that, we will do the digestion. We have anaerobic digestion, aerobic digestion, and we can also have sludge lagoons. Then for the conditioning, that conditioning may be use of chemicals, or we may also do the conditioning using heat. If we are talking about dewatering, we do have a lot of method. It is centrifuging, vacuum filtration, pressure filtration, drying baths, heat drying. We will talk about this. And oxidation, we have incineration, wet air oxidation. This we have learned a little, but we will again have some MCQ. So the next part is to talk about these methods one by one, right? And then ultimately we will get the ultimate disposal, that we can dispose in any landfill, or we do also have some technique to dispose it. We will talk about that also. Okay, which sludge thickening method? So the first process is thickening. We talked about here, right? In the concentration, we have thickening. So let me clear this. Which sludge thickening method is especially effective for activated sludge and increase solid content modestly? And we have four options here: gravity thickening, flotation, installation, composting. No, I think you need to, you gave me A answer, but uh, I don't think that A answer is the right one. You need to revise your answer. For the thickening, as I told you, for the thickening, we have two methods: gravity thickening and flotation. And one method is important for the sludge that we will get after primary treatment, and another is after secondary treatment, we will get the sludge. So, different technique is for the different type of sludge. And here in that question, we are talking about the sludge that we will get after after secondary process or secondary treatment process, because this is activated sludge. So for activated sludge, what kind of method is more effective? It is a flotation. Yes. So uh, just see that if we have, as I told you, uh, okay, let's start from the starting only. We had total solid, right? We had total solid. In that total solid, we had fixed solid and we had the volatile solid. Fixed solid, volatiles, okay, volatile solid have organic matter mostly, and volatile solid are also dissolved one. And we also talked about that the specific gravity is less of volatile solid. For fixed solid, we had less organic matter, but we had sand type of things, and that had more specific gravity, right? So, so after primary treatment, we will have more fixed solid in the sludge. Okay, after secondary treatment, we will have more volatile solid in the sludge. It means that if we do have fixed solid after primary treatment, that means we will have mostly sand, grit, and all these things in the sludge. So it means that for that, this gravity, because settling is very easier for it, because specific gravity is higher, so settling is very easier and faster. So for primary, the sludge that we will get after primary treatment, gravity thickening is more effective for that kind of sludge. But if we are talking about volatile solid that we will get after secondary treatment, because these are mostly dissolved in your water, these are not like at the bottom. So for this, we need flotation, and we will talk about this, what do you mean by flotation. But just keep it clear in your mind: the sludge that we will get after primary treatment, effective method is gravity thickening, and for secondary, the sludge that we will get after secondary treatment, the effective methodology will be flotation. Now let me talk about flotation only. So this is the process where air bubble or gases are introduced into the sludge that will cause light, solid, and particles to float to the surface. And that's how we can do the skimming. We can remove it from the top. Okay, and that is how we can concentrate that solid part. And this is best suited for activated sludge. Main purpose is to increase the solid, increase the solid content. And mechanism is, as I already have talked about it, we are giving air to that sludge, so that uh, so that the solid particle will be lighter and can go to the top, and that's how we can do the skimming. And this is effective for low density sludge. And as I told you, uh, primary treatment is giving you the higher specific gravity sludge as comparison to the secondary one, right? So this is how this flotation is effective for the secondary sludge. So that's how it was not the gravity thickening, but the answer is flotation. I think this is clear. Anyway, so which method significantly increase solid content from 1 to 3% to around 10%, typically for primary sludge? Flotation, gravity thickening, pyrolysis, environmental utilization. So yes, you people mostly gave me B and Sagar gave me C. Because here right now we are talking about yes, B will be the right answer, because let me show you once again. Here we were talking about how to concentrate it, right? And we had just two method, either it is thickening or flotation. For primary sludge, we need gravity thickening, and for flotation, we need the secondary. So that incineration and everything will come under like different processes. So here the answer will be gravity thickening. So so how we can significantly increase solid? So we are concentrating it, right? But this pyrolysis is not concentrating, it is reducing. It is not concentrating but reducing. But this method is accumulating all the solids together, right? So that's how this answer will be gravity thickening. Not flotation, because this is for secondary sludge. Not pyrolysis, because we are talking about here the concentrating, not reducing or any another method. And environmental utilization is not also the right answer. So B is the right one. So till now, what we learned is that for the primary sludge, we will use the gravity thickening. For the secondary sludge, we will use the uh, flotation thickening or the concentration. And after that, we will have different step that we already have. I already have shown you. Okay, so the next step was the digestion. After concentration, next step is the digestion. So what is the main purpose of sludge digestion? Increase sludge volume for easier transport, decompose organic solid, reduce mass, destroy pathogen, convert all sludge into energy only, avoid any further treatment. Okay, so Priscilla, Divya, Sagar, you gave me B answer. Venkateshra also gave me B answer. So yes, this is B. So the first thing is we already have concentrated the sludge. Okay. Next thing is how we can reduce that now. Till now we just concentrated it, but now the thing is how we can reduce it. So as I told you, that sludge all may have organic compound, and that organic compound can be convert into let's say if your organic compound is glucose, right? That glucose can be easily converted to CO2 and H2O, let's say. And this is how we can reduce the weight or volume of the sludge. So the one process is digestion. This digestion will be help of microbes. That microbes will decompose such kind of material for example glucose, that will decompose organic solid. This is how it will reduce the mass, and this can also have potential to destroy the pathogen as well, because some of the microorganism will do work at higher temperature. Okay, these are known as the thermophilic microbes, if you have heard about this. So if we are giving more temperature, then this is how we can also destroy some of the pathogen. So the main purpose of sludge digestion is to decompose organic solid, to reduce the mass, and to destroy the pathogen. So that's how B answer is the right one. So such kind of tanks we can have for this sludge digestion. So this is the biological process in which organic solids are decomposed into stable substance, and that will reduce the total mass of solid, that can also destroy the pathogen, and that would make it easier to dewater or dry the sludge. The next process will be dewatering and drying the sludge. Most common is anaerobic digestion in the absence of oxygen, and that digested sludge we can also treat in the lagoons as well. Along with that anaerobic digestion, we can also have aerobic digestion that we can also employ in small treatment plants. And because it is aerobic, then we have to give uh, oxygen to that, and we do have different methods that we also have to follow on. So this is sludge digestion. Which statement about sludge lagoons is correct? Water depth is usually less than 1 meter, designed purely based on sludge weight. Service life is 7 to 15 years with 0.2 to 0.5 meter cube per capita volume. Free body is not required. So the digestion, because digestion is the biological process, that biological process we can also can have in shallow pond like water body, right? So these are some, like, in lame language we can call it as a, if we do have shallow ponds, then we can call it as the lagoons, right? And in such lagoons, because there we can have microbes and we can decompose our sludge, so that sludge can also be treated in the lagoons. And you need to tell me the correct statement about the sludge lagoons. Let me see the answers here. I got Venkateshwara C. He also gave me C. Yes, so that sludge lagoon have the service life of 7 to 15 year, and that can take like 0.2 to 0.5 meter cube, that is per capita volume. The depth is less than 1 meter. This is not correct because the depth can increase. Design purely based on sludge weight, no, we have to take into consider more variable. Free body is not required, no, this is again the wrong statement. So C is the right one. So just see here, this is the anaerobic lagoons that we can create, and it is usually designed on a simple volume per capita basis that have the service 7 to 15, and the water depth is mainly 3 to 5, and freeboard of more than 1 meter is required. Okay. Because we right now we are talking about the digestion, and in anaerobic digestion we do have two stage, and you have to tell me what happens in the first stage. And we have four options here. Biomass is produced directly by acid forming bacteria hydrolyze large molecule into smaller soluble molecules and fatty acid. Sludge is incinerated, methane is combusted to generate electricity. Let me see the answers. Okay, so Venkateshwara gave me a B answer. I also agree with this B only. So what is happening if it is a two stage? Then this means first we have acid forming bacteria, and then this acid forming bacteria. So for first we do have complex organic material, right? Complex molecule. That complex molecule will be break down into simpler, but before that, that complex uh, would be into simpler, and then it will give you the methane like condition, right? It will give you the gases, for example methane. So for this we need acid forming bacteria, and for this we need methane forming bacteria. So in anaerobic digestion, we have two steps. First, we need acid forming bacteria, and then we need the methane forming bacteria. Acid forming bacteria will work under very high temperature, and that can decompose your complex organic compound into the simpler one. But because we need to recover the energy, then some of the bacteria, for example methane forming bacteria, that these are mesophilic. So mesophilic means that need ambient temperature. In that ambient temperature they will produce methane, okay, from your sludge. So that would be the second part. So just see here, first we need to create the buffer tank. Then we have hydrolysis acidogenic stage digester that will break down your complex organic compound. And then we have methanogenic stage digester that will give you the biogas, methane and all, right? So these are this is your first step, and this is your second step in anaerobic digestion. What is the main purpose of second stage in two-stage anaerobic digestion? We already have discussed about this, but this is MCQ. Hydrolyze protein and lipids, convert dissolved matter into biomass, biogas, increase sludge solid content to 10%, mix air for aerobic digestion. I think this is easier now because I already have that we have two steps. The first step will convert complex to simpler, and second stage, that simpler molecules will give you the methane like biogas. So yes, B is the right answer. Yes. So B is the right answer. So whatever you have dissolved matter, that will be converted into biogas, and that biogas will be used as a energy recovery. Okay, I already have given you explanation, Halaki. What is the main purpose of thermal hydrolysis in sludge treatment? And we have to combust sludge for energy recovery, to break down large molecule using heat before anaerobic digestion, to increase sludge water content, to mix air into sludge for aerobic digestion. And based on that explanation, I need to hide that explanation by, but I couldn't. So based on that explanation, I think that would be easier for you to give me the answer. um, what is the main purpose of thermal hydrolysis in sludge treatment? So, okay, now everyone gave me B answer. So, this thermal hydrolysis is important before anaerobic digestion. Okay, so before anaerobic digestion, we can follow one step, that is the thermal hydrolysis. So, in the under the high temperature, we can break down some of the complex molecules. Okay, it would not be easier, let's say, for organic sorry, for the microbes to break down that molecule. So that can be done using heat. Using heat, we can break down the large molecule before anaerobic digestion, so that would be easier uh, for the microbes to digest that. Okay, so that's how B answer would be the right. And here I also have given you the explanation somehow. The thermal hydrolysis use heat and pressure to hydrolyze large molecule, make sludge more digestible in subsequent anaerobic digestion. So it is making the favorable condition for anaerobic digestion. So before anaerobic digestion, we need to follow one step, uh, thermal hydrolysis. If organic material is very complex compound, so that's how B answer is the right one. During thermal hydrolysis, why is the sludge suddenly released into a flash tank? To aerate the sludge, to burn off excess water, to burst cell wall and enhance hydrolysis, to cool the sludge for storage. So suddenly we have to release that sludge into flash tank. But why we are doing this? What is the main purpose of this? Priscilla, C question mark. Okay. Yes, you are in the right direction. So why we are doing it sudden? Because this is how we can burst the cell wall and we can enhance the hydrolysis. That's how we are giving suddenly the higher temperature. So just see, we do have different steps that we have to follow. So for example, first we have sludge, then we will preheat that at 100 degrees Celsius for 1.5 hour. Then we will give that steam also, and then we will add some solid, and then we have the flush tank as well. So here we will give the suddenly we will put that sludge into this flash tank, and this is how this will help us for the anaerobic digestion. So this is the part of your uh, thermal hydrolysis. Okay, as I told you, we do have different steps. So we need to sometime whenever we are doing this thermal hydrolysis, so we have to dewater the sludge also. But in the next few slides, you will get to know what you mean by this dewatering the sludge. And the important part was this one, flash tank, so where we will drop the pressure. So the hydrolyzed sludge is suddenly released into the flash tank. This will cause a rapid pressure drop, and this sudden decompression will burst the cell wall of the solid, exposing more organic material, and this is how this will improve uh, the digestion process. Okay, so I think this one is clear up to now. We talked about gravity thickening, we talked about flotation, we talked about anaerobic digestion. We didn't talk much about aerobic, but just you need to assume that this is kind of digestion or breaking down the uh, organic matter into CO2 and H2O in the presence of microbes, but here we are giving the oxygen as well. And we also talked about this sludge lagoon. So this much we already have completed. Now we will talk about this conditioning and dewatering and oxidation. Okay, so the next will be conditioning. Why are cationic chemical used in sludge conditioning? So the first thing is, in sludge conditioning, we are adding some chemical, and in that chemical, we are using cationic chemicals. So why we are using cationic chemical in sludge conditioning? We have four options here: to increase negative surface charge of sludge particle, to neutralize electrostatic repulsion and promote flock formation, to combust sludge for energy, to oxidize organic matter. Let me the answer that you have given me. So Priscilla and Venkateshwara, Dia, Sagar. Okay, everyone gave me B answer. So yes, so this is to neutralize electrostatic repulsion and to promote the flock formation. That's how we are using the cationic chemicals. So just uh, so okay, why we are using the sludge conditioning is that we need to improve the dewatering property. We will talk about this, how we can remove the water from the sludge. Till now we are concentrating it, or we are removing the organic matter, but still we do have water in the sludge, and we need to remove that because as we already have discussed, sludge is your semi solid slurry, right? It has the water. We need to remove that water, and to remove that water we need dewatering technique. But to make that dewatering technique easier for us, or to be feasible, we need to have conditioning method before dewatering. Okay, and this what we will have: sludge particles are negatively charged, mostly negatively charged. These are anionic. That will create the electrostatic repulsion, and that would hinder the settling and the compaction. But if we are using that cationic chemical, that will balance this negative charge, and that will reduce that repulsion as well. So a flock can be formed. So this is the pre-treatment step before dewatering. Okay. So here we can use chemical conditioning. So we can add some chemical into the sludge. So for example, if it is a cationic chemical, then the example will be iron salt, alum, lime, polyelectrolytes that we can add for the conditioning. And we can also use thermal conditioning. uh, so we can provide heat to the sludge so that we can break down the gel structure of sludge, so that it can release the water. As I told you, conditioning is the pre-step for the dewatering, right? So that so we do have two type of conditioning: chemical and thermal. Okay. uh, as I told you, we already have talked about this thickening, right? And another term is dewatering. So how this thickening and dewatering is different to each other. So sludge thickening is best distinguished from dewatering because it mainly reduce. We have four options here: capillary water within sludge flocks, flock bound water content, a free water present between sludge particle, moisture converted to water vapor. How this sludge thickening, that was the first process, right, is different from dewatering? What do you think? What should be the right answer? Little trickier, right? But I think you can tell me. You have that potential. Okay. Let me see. Okay. So yes, Sagi gave me right answer that it is mainly it mainly reduces free water that is present between sludge particle. And okay, so I have one slide here by which you can understand. So we have sludge thickening, and we also have this sludge dewatering, right? So in sludge thickening, we we can reduce free water. Okay, but if it is dewatering, then even we can extract the capillary water. I think you know the difference between the capillary water and free water. You must have heard in that soil we have capillary water and we also have free water. So likewise, so even after this sludge thickening, the sludge will have liquid, or it may also have semi liquid state. But if we are going through the sludge dewatering, it means we are converting into the solid or semi solid cake, right? And typically in thickening we are removing 92 to 96% water, but in dewater we are removing 60 to 80% water. As we already have learned in the thickening process, we learned about this gravity thickeners and flotation, right? But in sludge dewatering, we do have different filters. For example, if we do have cloth filter, or if we do have centrifuge, so, and even we do have drying beds. We will talk about these terms: filtration, centrifuge, drying beds. These are different methods under this sludge dewatering. Then uh, and use for this thickening is mainly a pre-treatment step before digestion, and dewatering is mostly the final volume reduction step, right? Okay, so we already have covered thickening, but right now this is the time to discuss about the dewatering, right? So for after that dewatering, we will have either solid form of the sludge or semi-solid. So for that, we have filters. We can use some filters. We can have drying beds, and we can also use dryer. For example, like for the hair, to dry the hair, because here also have some water, we are using the dryer. So likewise, sludge have the liquid, we can use some dryers by which we can volatile the water part, right? And this is how we can have the solid part remaining. This is how it will reduce the volume, and even reduce the volume. So we do have different methods of dewatering. Let's talk about it one by one. Which unit is less relevant for sludge dewatering or drying operation? Filters, drying bed, dryers, aeration tank. Okay, so Diya, Venkateshra both gave me B answer. Sorry, D answer. Yes. Uh, in the previous slide only, I told you different method of dewatering is we can use different filters, we can use drying bed, we can use the dryers to make our sludge into solid form. But this aeration tank is out of box option, right? So that's how D is the right answer, because this is least relevant for the sludge dewatering. So D is the right answer. Sludge conditioning is required before dewatering filter, mainly to increase the soluble BOD and COD removal efficiency, coagulate solid and improve drainability, reduce sludge volume by evaporation, convert free water into vapor for easier removal. Oh, sorry. I have, yes. Let me see the answers. Okay, I get B answer and A answer, but I will agree with this B more, because as I told you, the sludge have negative charge, right? And there is a negative charge, so there means there is a lot of repulsion. But to make them together, we need um, cationic chemicals, right? So that we can coagulate the solids, right? So that's how B is the right answer. But Note A, increase the soluble BOD and COD. No, BOD, for BOD and COD removal, we used digestion. We already have used digestion, but sludge conditioning, we have to coagulate the solid, right? We have to remove that negative charge from the sludge. So that's how B answer is the right one. So again, sludge conditioning, we are using chemical. We are adding that chemical into liquid sludge so that we can coagulate the solid and we can also improve the drain ability. And the filtration of primary sludge is only partially effective as treatment because this much are water soluble and so cannot be removed. Okay. So, because we are talking right now about the dewatering, one of the method to dewater the sludge is rotatory drum vacuum filter. So, we are using filter that is based on the vacuum, and you need to tell me what is the working principle of this RDVF. So, this is the part. This is the one of method of dewatering, right? So we have four options here. Sludge is evaporated by heat and then pressed into a cake. Sludge is sucked through a moving septum, forming a sludge cake that is washed, partially dried, and discharged in one cycle. Free water is separated from sludge solely by gravity thickening. Soluble COD and BOD are completely removed during filtration. I think from option only it is very clear, and you people also gave me right answer that this is B. So what we are doing here, so we do have some moving septum, some compartment, and that is sucking the liquid. And if the liquid will be sucked using vacuum, then it will form some sludge cake that would be solid in nature, right? That sludge cake will be washed, that would be drier, and that would be discharged in one cycle. Let me show you. I have this figure. So this is that instrument. The instrument name is RDVF, rotatory drum vacuum filter. So RDVF is looking like this one, and let me show you the principle. So this is something. So we are giving a sludge and it will rotate. Then after rotation, and at the center we have the vacuum. That vacuum is sucking the water, and we are washing it also, and then we are dewatering it, and then this solid product will be we also have knife that will cut it. So a lot of things will be happening this. So a liquid will be sucked, that will form a sludge cake, that will also be washed, that would be partially dried, and that would be discharged in one cycle. So this is how this RDVF will work. Okay, which of the following statement about RDVF is correct? It can operate with high pressure difference since it is a vacuum filter. Cake of various thickness can be obtained by adjusting drum speed, but the system struggle if feed condition fluctuate. The initial cost is low, but maintenance costs are usually high. It offers full flexibility to handle variable feed condition with minimal performance loss. So this is about the advantage and disadvantage of using the RDVF. So you need to tell me which one is the correct statement about the advantage and disadvantage of RDVF. What is the limitations? What is the benefit of using RDVF? So based on that, you have this question. Okay, so B is the right answer, and let me show you why. So these are the advantages and disadvantages. If we are talking about the advantages, then this is very automatic in nature. And the cakes that will be formed of this sludge, that can be built by varying speed, and that would be easier for us to easy removal of fine or coarser solid, and it also have low maintenance cost. But along with that, we do have some disadvantage. You can read from this, and from this advantage and disadvantage only we had this question. So we can adjust the drum speed, but the system will struggle if the feed condition will fluctuate. So this is the positive side, and the next part was the negative side of this RDBF. Okay, the another method of dewatering is horizontal belt filter. And you have to tell me, compared to RDVF, horizontal belt filter are better suited for fine particle with low solid content, coarser particle with larger filtration area, removing soluble BOD and COD completely, small scale laboratory application only. So we use RDBF. Then what is the use of horizontal belt filter? And this is one of the method of dewatering only. So let me see. Venkateshwara gave me B answer. Okay, they also gave me B. So yes, so if we do have coarser particle and if we do have large filtration area, then we can use horizontal belt filter. Let me show you how it so this is belt, and that belt have a filter. So if you can see this yellow color, so this is nothing but this is your filter cloth. So on that filter cloth you will have the sludge, and then filter cloth can suck that water, and that can give you the drier or dewatered sludge. So it is suitable for the coarser particle as comparison to the rotatory drum filter, and this is how it will work. Okay, the next method of dewatering is filter press. And in the filter press, slurry is fed under pressure, and we have four options here. Solid pass through the canvas while liquid form a cake. Liquor passes through the canvas while solid forms a cake. Both solid and liquid pass through the canvas simultaneously. Only soluble impurities are retained in the compartment. Okay, so Priscilla, B, Dia all gave me this B answer only. So yes, so here what we are doing, we do have canvas. So canvas is something like cloth, but here we are also giving some pressure. So after that pressure, what will happen? The liquor will pass through the canvas, and upon that, above to that, we will have the solid sludge, and that solid sludge will form a cake. Okay, so this will be under filter press. Let me show you. So such kind of filter press we have, and this is how it will work. It can give you some pressure. So you see here, it contains a set of plate designed to provide a series of compartments in which solids are collected. And here filter media is such as the canvas we can use, and we are giving pressure, and that's how that pressure will give you the water that will pass through that canvas, and that will go out through a discharge pipe, and that will leave a wet cake of solid behind. Okay, so another method of dewatering is dewatering centrifuge, and that would separate solid from liquid mainly by gravity settling in the thickener, high pressure filtration through canvas, rapid rotation of a cylindrical bowl, and evaporation of water as vapor. So now you have to tell me the principle of centrifuge. Okay, Venkateshwara and Dia both gave me a C answer. So yes, if it is a centrifuge, right? So most of the time we are having the rotation of some cylindrical thing. So let me show you. So this is how. uh, this will move, the cylindrical bowl will move, and this fast rotation of this bowl will separate your liquid from the solid. Okay, and this is how the wastewater centrifuge dewatering process remove more water than another method, and that leaves solid material, and that solid material is known as cake. So this is very effective to separate solid and liquid from of the sludge, right? So, and this process is also known as decanter. So you have learned a lot of thing about dewatering. RDVF we had, centrifuge we had, then horizontal belt, then filter press. A lot of method we already have discussed about the dewatering, right? Okay, so these were the filtration part. Okay, the next will be the drying beds. So drying bed will also dewater sludge. So like we had in the dewater, we had three steps, right? Or three methods. The one is by filters, the second is by drying beds, and third is using dryers. So we have completed the part of this filter. Now we are talking about this beds, and then we will talk about the dryers. So the sludge drying bed dewater sludge mainly by centrifugal force and high pressure filtration, evaporation and gravity drainage through sand, heating and vacuum suction, chemical coagulation and flocculation. So everyone, I think, gave me B answer for this. Let me see. Priscilla, Venkateshwara, Sagar. Yes. So everyone gave me B answer. So yes, so this is something we are using here, drying beds. So we have bed, or we have a larger area, and that larger area have the sand, and on that sand we are lying down the sludge, whatever sludge we will have. So because we will have the sunlight, in the presence of sunlight there will be evaporation, and we will also have some gravity drainage, and because of that we can dewater the sludge. So this is the drying bed. So something like this we can use, but it will take a lot of area, and even a lot of days it will take to give the solid content, right? Okay. uh, in sludge drying, which of the following correctly match the process with its type? We have indirect and direct drying, right? And you have to tell me which one is correctly matched. So we have four options here: fluidized bad dryers, indirect drying, disc dryer, revolving drum dryers, and fluidized bed dryers. So we have two type of drying: direct and indirect. Dia gave me a C answer. Yes, C answer is the right one. So just see here. If we are having the direct drying, so sludge is directly contact with a heat surface, and that would be fluidized bed dryer or revolving drum dryer. And if it is a indirect, so there is a no direct contact between heat source and sludge. So the one example is the disc dryer. Okay, so up to dewatering, you already have talked about centrifuging, vacuum filtration, pressure filtration, drying beds, and heat drying. We already have talked about this dewatering. I think one dryer is left, but after that we will have oxidation. So this is the next step we are coming to. Okay, so sludge oxidation process such as incineration and wet air oxidation are mainly used to increase water content before disposal, reduce organic content before final disposal, convert sludge into fertilizer without heat, separate solid from liquid mechanically. Okay, so everyone gave me a B answer. then yes. So even after digestion, even if we do have some organic content, then we have to rely on oxidation process, and that oxidation process have incineration and wet air oxidation that will reduce the organic content before disposal of the sludge. So this is kind of last step before disposing the sludge. Which of the following correctly describes sludge incineration? I think you can tell me. This is very easy. Sludge can be directly incinerated without prior dewatering. It is a single step process of combustion only. It requires prior dewatering and involves drying, combustion, and flue gas treatment. No auxiliary fuel is needed since sludge burn on its own. Okay, so Priscilla and Sagar give me C answer. Yes, so C answer is the right, because this is oxidation, and this oxidation is your last step, right? But before that, we need to dewater, and that dewater involves drying, and in incineration, we should have combustion and flue gas treatment as well. So C is the right answer. So this is again and again I'm showing you just to make it clear where we are and what we are learning, right? So we are learning this last step. Okay, so we have learned this part. Then the left part is composting and anaerobic digestion. I think we will not be able to cover industrial pollution control measure. We will try to cover that into next session, because like from the starting only we can start this, because in the next session also sir will cover this industrial pollution as well. Okay, so the only left remaining part is composting and anaerobic digestion. Let's cover it in 4 minutes, and then we will have the dinner time, right? Okay, so now your sludge is ready to for the disposal. Okay, now you have to tell me how we need to dispose it. We can't throw it, right? We can't throw it on the side of your rods. We have to dispose it properly. So which of the following is the safe and commonly used method for final disposal of treated sewage sludge? Spreading on crop for human consumption, buried in a sanitary landfill, or used as a soil conditioner on non-food land, dumping in the ocean, feeding directly to hogs. Okay, so everyone is giving me B. Yes, B is the right answer, because directly we can't use it on crops, but we can use it on some soil that is non-food land area, right? We can use there. We can't dump in the ocean. Initially we were dumping in ocean like in a very huge manner, but I think USA and all has banned this dumping in the ocean, because this may give you the harmful impact. Feeding directly to hogs, so this is kind of food for the pigs, so this is also not the safe method for the final disposal. So the only is we need to bury into the sanitary landfills. So these are some convention method, but the most common is we should have this landfill sanitary. Okay. Uh, uh, See, after making it solid, some of the water uh, we already have filtered. So the thing is, we had the wastewater, then we purified the water. That water we need to we can use for the drinking water, as a drinking water. Then we had the sludge also had some water. that water uh, that water we can also use, right? And that sludge will form the solid part, but sludge also had some liquid part, and this question is on that liquid part only. So which of the following is the convention method for disposing desalination concentrate? Incineration, deep wall injection, sludge feeding to hogs, ocean dumping. because now we are talking about the liquid part of the sludge. Solid part, for the solid part, a sanitary landfill is the most common. But if we do have that liquid part, and that liquid part also we already have done this desalination. So what we will do of that liquid water? So yes, Sagar and Priscilla gave me B answer. So yes, we can uh, throw that water into deep well using injection. So we can inject that water into deep well. uh, okay. Okay, so we have some methods, uh, some method of this sludge treatment, and or some technology. In that technology, we have multiple methods. That method may be digestion. We can also have dewatering. We also have like oxidation within the same technology. So you need to tell me which technology use thermal hydrolysis coupled with anaerobic digestion to reduce sludge solid, and that can increase the biogas production. So we do have a lot of technology like this, but access and biothides is the one of the technology that we can use. Okay, so the next part is whatever that answer was B, not D. Okay, so sludge we can throw it in sanitary landfill, but we can also use it as the compost. For that compost, sludge should have uh, uh, some particular C and N ratio, carbon and nitrogen ratio, or the proportion of nitrogen and carbon should be uh, very specific to make that sludge into the compost. Okay, and that ratio is, yes, it is 25 to 30. A lot of factor uh, we have by that will affect our composting process, and you can read about this. Then in that composting we have one that is windrows. So these windrows will support the structure and improve. So here we are talking about the bulking agent. So that bulking agent will support the structure and that will improve the aeration. So this is windrows, and in which we do have also the bulking agents. So I think this one is okay. uh, and anaerobic digestion, we already have talked a lot about this. And then these are some, like I had two numerical question based on specific gravity that you already have learned. So yeah, this formula you already have learned. So based on that formula you can solve the numerical. Then another question was on thickening. You can read about this as well. And this is how we are finished till anaerobic digestion. In the next week we will touch this industrial pollution control measure and more another content that we will cover uh, next Monday 7 to 9. And thank you so much for the patience. And this is how, if you have any suggestion or query, you can let me know. You can anytime mail me, and you people are encouraged to do the participation. So thank you so much to listen very patiently. And this is the dinner time. You can go and you can have a good dinner. So thank you so much. You can leave now.